You may have noticed during the testing of the bucket in the last video that when the boom is brought down, it kind of jerks before it moves, or it starts to move and then it jerks and kind of goes down, you know, holds up and then drops. We're going to see if we can fix that in this video. When I had the loader arms off for paint, I was cycling the lift cylinders to bleed the air out of them because I had them off and I cleaned them out and all that. And extending them out went just fine. They went out nice and quick, but retracting them was super slow no matter how much I pulled on the lever. So there's some sort of restriction in the control valve not letting enough oil through. And I think it's something that's just sticking because with the loader arms on the machine, that weight, it kind of forces the cylinders to retract when you want to lower them. And it's like it gets past that point where it's kind of holding up and all of a sudden the loader arms start going down quite quickly. So I think it's, I don't know, without any weight on them, they don't retract very fast at all. But with the loader arms on there, it sort of forces that valve or whatever's in the loader control valve that's sticking to move past that sticky point, and then it starts to move down all of a sudden. That's what's causing that jerking motion. I'll see if I can show the jerking better here. Just in case safety stick. You don't want that thing coming down on your head. So here's the lower control valve. It's pretty dirty. Under one of these plugs, maybe that guy down in there, there's some sort of check valve. I have to go check the manual. It Looks like we've got a bit of a leak back there. Yeah. I think it's from this hose. It's dripping right there and then running down. This hose is the main pressure from the pump up to the loader control valve. Anyway, that's not our problem right now. Should get this cleaned off a little bit and go look at the manual. So here's my logic according to the manual. Get this out of the way. Go all the way over here. Now this is the loader circuit, loader raise and lower circuit. On the raised circuit, when the spool is moved, it blocks the center passage because it's an open center type of hydraulics. Pops the load check and then starts flowing. Same thing happens on the return. The spool is shifted the other way and the load check is popped, and then oil starts flowing. So I don't think it's the load check because it seems to work fine raising the loader arm but not coming down. And that would be affected, that would affect both of them if it were the load check because it's in both circuits. Now the thing that's different, when the loader is raised, it goes through the load check, and then on its return circuit, it comes back through the port and into the open center. But when you're lowering the loader arms, it goes through the load check, and the return oil comes back into the open center, but it wants to pass through the series check valve first, and then go on to the open center. Now this is the check valve. The check valve is for shock loads, but it's also got an anti-cavitation function, so it fills the cylinder. If the cylinder were to move for some reason, you bump it into something or whatever, and it moves without oil flow there, this fills that up. So since this circuit relief and anti-cavitation check valve is on the return side, when it's in lowering, I'm thinking I'm going to start there and just see if it's sort of binding or sticking. Well, I don't see anything wrong with this. You know, there's no big scratches or anything, like it's binding, it doesn't want to allow it to slide or any of that stuff. So maybe it's not this. It's kind of hard to check, but I'll see how it moves in the bore. Probably won't be able to see that on camera. It's way too tight in there. Okay, so I ended up pulling the rest of these plugs. Some of them were other circuit reliefs. One was the load check valve in the middle. One was just a plug blocking off a passage. Kind of hard to see, they're all in there. And I didn't find anything wrong. Nothing rusty, nothing scored. So nothing was binding, or all those little valves and stuff seemed to be sealing and moving properly. So I don't know, I guess we're gonna have to look somewhere else. Okay, after a little more research, I'm gonna pull the counterbalance valve. Now there's actually two counterbalance valves. This is one, that's the one I'm gonna pull. And there's another one down there, comes in on the side. That one's for the bucket and everything, but this one is for the lowering of the loader arms, which is where the problem is. It's supposed to hold, it's supposed to not let a load drop, basically. It's supposed to allow you to control it. You got a heavy load in the bucket or something, allows you to bring it down to the ground safely. So I'm thinking something in there is sticking. To get that thing out of there, I have to pull these two solenoids because they're in the way. These two solenoids, they basically lock out the loader controls. So unless you have your lap bar down and all that, it won't allow you to move the loader arms. Yeah, that's all it does. It's got a little rod on the end. When the solenoid's engaged, it just sticks out and sticks into a groove on the spool, and then you can't move it. Wow, that's loose. I did not, that's crazy. I guess somebody has replaced this one before. It's supposed to have a plug on it like that one, but they just hardwired it in. You know, who does that? So now I have to get it out while twisting the wires kind of and try to keep it. I mean, I guess I could put some sort of plug on there, but I'll mess with that right now. Let's see here. .67, 29. I got a 30 mil socket. I guess it'll be close enough. That looks like something's smushed right there. Get this cleaned up and have a look. Okay, so we got O-rings and backup rings on each row here.
And the one that's smushed looks like somebody's put in 2 O-rings. You can kind of see it's sort of stuck right into the thread. I don't know if that's another backup ring or not. It almost kind of seems like it's an O-ring. We'll take them off and we'll see. But even the manual kind of looks like it's wrong. In the picture here, it's got 1 and 2. 1 is an O-ring, 2 is a backup ring. So they got the backup ring on the inside where the pressure is. I would have thought the O-ring should be where the pressure is. Crappy snap ring pliers won't close all the way. Give it a little help. There we go. So I pulled this piece out too. And this is the backup ring. Not much of a ring. I don't know why, there's almost nothing left of it. So it slides down in there like that. Now I can't get that out. Way down in the middle there. I don't know if it's supposed to move freely or what. But we'll replace these O-rings and just see if it makes a difference.
The new O-rings on the low control valve did not fix the problem, and I've consulted the fine people at Heavy Equipment Forum, and we're going to move on now and check the actual cylinders themselves, the lift cylinders here. It's hard to tell, but in operation one cylinder actually starts to move a little bit before the other. Something's going on where they're one's stronger than the other, or there's some sort of seal inside that's messed up. The cylinders have been repacked before. There's marks from a pipe wrench on there. So I don't know if somebody put crappy seals in, or the seal just got out of place somehow and it's binding or dragging, or something's causing one cylinder to be stronger than the other, and I think that causes a binding situation where the loader arms has to overcome it before it moves down properly. Okay, that's all tied up. I got 2 straps and a chain. The straps are actually tight, so they're holding it. They're rated for 1,000 pounds each. And the chain is just there for safety. So the end of these cylinders, there's 2 flats. One there on the opposite side. They're 74 millimeters apart. So I'm gonna have to make a wrench for that. The last guy who did this used a pipe wrench. A little more visible on this one. You can see where it really dug in there. I painted over it all when I repainted it, but those marks are still there. So we got to get these cylinders opened up and see what's going on inside. There it is. Might be a little hard to see. Got my wrench laid out. I'm gonna put a little bend into it just so it's easier to get in close to the cab. There we go, that's starting to look like a wrench. I just measured this. I got about 72 mil on the inside, so that was pretty close. I need 74. Just enough room to clean it up. Well, this side's a fighter. I think my wrench is starting to spread. Oh. Yep, it's slipping. Since the jaws were spreading, I made this bolt-on U-shaped plate here. So it'll hopefully keep them from spreading, and we'll just have to try it out and see. I think we're still slipping. You can see how the corners of the gland nut just dug right in. If that shows up. Yeah, there it is. It's just digging right in. Kind of smushing it. I mean, this is just mild steel, but that's on there pretty tight. So I think it's time to stop playing around. There we go. Some results. Now I just got to get in there and cut that wrench off somehow. This bolt locks the pin in place. And it's not really good or bad on this side, but the pin goes inward. You got to hit it that way towards the engine to get it out. The other side's more annoying because you got to remove the hydraulic oil filter to put the pin through. There doesn't seem to be much wrong with the pistons or the insides of the tubes, but when I slide these glands back and forth, they make a bit of a metallic sound, one more than the other. That one's not too bad. This one I think is worse. Yeah. You're not going to be able to see this very well, so I'll put some pictures up. But this one has some rust on the inside here, right on the first land. That one wasn't grabbing very much, so that one wasn't really the problem. This one doesn't really have any rust, but on its land it has some metal burrs. And that's the one that was grabbing a lot more. Now, I don't know exactly why it's doing this, but I'm going to clean them up, put them back together, see what happens. These glands don't have wear bands inside of them, but from what I've researched online, when they don't have a wear band inside, they're made from a softer material, so the whole gland itself is kind of like a big wear band. and well, it's been doing a little bit of wearing, so get that cleaned up, take out the sharp edges, and maybe it won't grab so much anymore. Okay, so to clean up the sharp edge, I'm just taking a piece of sandpaper. This is 320. Fold it. Dip it in a little bit of hydraulic oil. And then it's hard to see, but okay. You got to get right in on this lip here. So stick it in underneath the seal, and then kind of push down so it'll be riding on that inside edge, and then just work it back and forth. And it's actually cleaning up pretty quick. Just got to get rid of that sharp edge. Okay, there we go. Now we've got a rounded edge in there instead of a sharp edge with burrs on it. I've got it marked here as well. I want to try to tighten it so that it's in the opposite orientation to how it was before. Maybe that'll help. The right thing to do would probably be to put new seals in, but these ones are still working, and I want to see if the problem goes away. Plus, it's a long weekend, and I asked the dealer how much seals would be for these cylinders, and they said it'd be about $500 just to do the piston and the seals inside the gland. $500 for both the cylinders. Kind of ridiculous. So we're going to see how it goes. I especially want this area up by the wiper seal to be filled with grease because oil doesn't really reach it. And that's where the rust was in there. So hopefully the grease will keep that from rusting again. There we go, it doesn't grab anymore. I'm also going to grease up this area here, this O-ring. Just getting a little rusty in there. Okay. All right, let's wiggle this sucker in there. tightening up those glands once it's on the machine. This is supposed to be 300 foot-pounds or something like that, but we're just gonna make it as tight as we can with this pipe. Now, you're not really supposed to use filter wrenches to tighten filters, but this one's hard to get at, so we'll just help it out a little bit. There we go. Get this thing off. Well, I don't know if it's any better. Maybe it does need new seals. Maybe that would help. Seems like it might be just a little less grabby, but it's definitely still doing the thing where it jerks when it goes down. Okay, I want to test the system pressure. So this is a cap that goes into the line right after the pump. Test port, I guess, and I welded a -6 end onto it, female end. That way I can put one of these -690, and then I can screw a -6 fitting into that. And then I drilled and tapped this end out, the 9/16 thread, so that I can put my fitting on here that accepts the line from my gauge. That'll screw in like that, and it's got a little rubber ring there, so it just butts up. And then you take this cap off, and that's where the hose for the gauge will connect. And then when I'm done testing, I welded up the end of one of these -6 fittings so that I can screw it into here. And then this cap, it'll be like a cap again, but I'll have a test port on it. Okay, there we go. Now I can hook a line to it. Well, it's in the shop. Things are getting serious. Control valve's gonna have to come out. As you just seen, the pressure gauge probably didn't make much sense, but all the functions take 400 to 500 psi. That's bucket curl, bucket dump, loader raise. But loader down takes about 2,000 to 2,500 before it starts moving, and then it's about 1,800 to 2,000 as it continues to move. So something in the control valve is really restricting the flow. I've been capping off other things like this. These two lines down here on this solenoid blocker for the ride control, they're tied into the lines on the cylinders. Capped those off, tried it out, made no difference. Capped off each cylinder individually, that made no difference. Had the cylinders disconnected from the loader and just sort of resting on the tire here, ran them in and out, and even with no load on them, it still took 2,000 psi to retract them. So we've definitely got some sort of blockage going on. It's either in the lines, but it affects both cylinders, so the lines branch here. It would have to be a weird little blockage somewhere in there, so I kind of don't think it's in the lines. There's got to be something floating around inside the control valve itself, and it's just causing an issue. Well, doesn't that look lovely? Oily mess. Gonna have to plug these holes and give this thing a bath. Supposed to be an identification tag somewhere over here. Maybe we'll find one. Okay, so I've been pulling apart the control valve. Comes apart pretty easy. And everything's been looking good. It's mostly internals here. There's just a few things, like somebody's been in there before and there's a backup ring missing here and there. Little stuff like that. But then I got to this part. This is the flow divider cartridge. And these are backup rings that are just totally shredded. I don't know where the rest of them are, but I didn't really find any in the control valve, so a lot of the stringiness is here, but it probably got flushed around and out into the rest of the system, collected by the filter. So I'm going to say this is a problem. Now we're going to have to figure out all the different seals and stuff I need. The control valve itself is looking pretty bare. Just a bunch of holes now. This big hole here is where that flow divider cartridge goes. And it's connected directly to this port and a few others, but that port is also connected to the lift cylinders. So I don't know, this has got to be affecting it somehow. We've got to get this all figured out and resealed, and hopefully that'll be the fix to the problem. Okay, I've been reassembling with new backup rings and O-rings. Not much to see there. But this is the one that had the shredded backup rings. You can see here we got two new backup rings and the O-ring on that one, and I've got a bunch of here and some extras. These backup rings actually have a, you probably can't even see that, but they have a really slight concave surface to them on one side. So I'm putting that facing the O-ring. And hopefully that'll solve the problem. I found out that the shredding of the backup ring is usually because the O-ring gets old and hard and it starts bypassing oil, and as the oil bypasses it has to fit through a very tiny crack there. As it does that, it heats up so much that it actually starts to melt and make the backup ring kind of string out. So all that shredded backup ring was because oil was going the wrong way. So I'm pretty hopeful that this is going to fix the problem. we go. This last groove here is actually not used on my control valve. It's actually that little one that I showed earlier with the shredded backup ring. It's actually on the opposite end of the same circuit as this. So I don't know. It's weird because inside mine there is just a casting that's rough when you get to this point. So no O-ring would actually help at all. And they must have changed that later on, because in the later versions it doesn't show that little guy and it's just this one, and there's O-rings on here. So they changed something internally on the later ones. Anyway, that's ready to go in. You rebuild things, you gotta paint them, right? Otherwise, how do you know it's been rebuilt? I got a new pressure line made. This is the old one that was leaking at that crimp there. And it was also leaking at the other end where it goes into the control valve. And flip this over. You can see it was rubbing up against the inside. And it's some sort of weird abrasion going around it as well. So the new one should fix that. And I got it a little bit shorter, so maybe it won't rub up against the inside so bad. Shortening the hose was the right move. It's kind of hard to see. I'll go up from the other side. Maybe you can see there. No, let's try. There we can see right down in there. Just clears now. It's got about 3/8 of an inch clearance to the side. Off camera, I've done a couple things. I really didn't know if they would work or not, but I ended up changing out a few O-rings.
that were kind of questionable. And I also wet sanded with hydraulic oil one of the little pistons. It's way back in there underneath the relief valve. It felt like it was hanging up a little bit, but I don't know if it was hard to tell. So anyway, I wet sanded it a bit, get rid of the burrs on it, put it all back together, and there's an improvement. Now it only hits 1200 psi or 12 to 1300 psi when I want to bring the loader down. So it's not spiking up to 2500 anymore and then dropping to 1800. So that's good. I don't know exactly what I did, but it seems to have kind of solved the problem. I talked to a hydraulic guy and he was saying that because I have counterbalance valves, this one and there's another one down below there, he was saying that it's possible that the lowering circuit will have pressure in it like that. Not the 2500 obviously, but potentially the 1200 or 1300, because it's there to hold out the load. And he was saying I need to test it with a load in the bucket and see if the pressure becomes less. Anyway, I haven't tested it with a load in the bucket yet because as I was putting this thing all back together, there's supposed to be a big solenoid coil on the backside here, and that's what cancels or enables the self-leveling of the bucket. And it decided to short to ground while it was out of the machine. It broke. Quite the coincidence. So here's a new coil. This is what it looks like. Basically just slides over the valve thing in the back there. And when it's energized, it creates a big magnetic field and it pulls the spool in and out, which enables or disables the self-leveling. There we go. Put some never sneeze on the nut, because you might be back in here and you don't want that thing seized up. Where is that thing? There it is. Okay, I'm going to show you that it doesn't jerk or clang when bringing it down anymore, and the self-leveling can be turned on and off. Well, I think that's about it for this repair. I still don't fully trust it. I'm gonna have to use it for a while, make sure the problem doesn't come back.
You know how it is. You never really fully trust, especially when I didn't, I don't really know exactly what I did besides changing O-rings and wet sanding that one part. I mean, maybe that's all it needed. I mean, I guess that's all it needed because it's working. So I also don't know how this thing was supposed to react, like, when it was brand new, because it's used. So I don't know if I have it exactly back to the way it's supposed to be, but I'm going to use it and we'll see how it does.